Hi, in this video we're going to take a look at the second exponent law, which is quotient law. In this law, we need to divide and subtract. In product law, we had to multiply coefficients and add exponents. In quotient law, when we have division, we divide our coefficients and we subtract our exponents. Remember that a base is not a coefficient, so we'll take a look at some examples now. For a, we have two bases, 3 to the power of 6 divided by 3 to the power of 1. Remember, that's our invisible exponent. Because we have bases, and these bases are not coefficients, we are not going to do any division at all here. The bases are the same, so we keep the base, but we're going to subtract our exponents, giving us 3 to the power of 5. Just to show you in expanded form, 3 to the power of 6 is 3 multiplied by itself 6 times, over 3 to the power of 1. If we cancel these out, what are we left with? We're left with 3 to the power of 5. So that's what we're doing using the quotient law in a shortcut method. Same thing goes here with b. We have a base of 4 and we have exponents 9 and 5. We're doing division, but there's no coefficients to divide. It's just bases. So we keep the base and we subtract our exponents. 9 minus 5 is 4. So simplified, this is 4 to the power of 4. Pardon me. For c, we have n to the power of 7 over n times n to the power of 4. So what we have to do for this one is we actually need to simplify the denominator before going ahead. That would be what we would advise you to do. So n to the first power multiplied to n to the fourth power means that in the denominator, we're going to add those two exponents, getting n to the power of 5. Now that we've got that, we can go ahead and further simplify. Same bases, n and n, top and bottom, so we can subtract our exponents, leaving us with n squared. For this next one, d, we have x squared over x to the power of 6. Same bases, no coefficient, right? 1 divided by 1 is nothing for coefficient. 1 divided by 1 is 1. So we're just going to subtract our exponents, but oh, we have a problem. This means x to the power of 2 minus the 6 there. We're going to end up with a negative exponent. Now this doesn't happen very often, and in polynomials we're not allowed to have negative exponents. If that happens, what you can do is you can pop that x down in a denominator. That will take away the negative. So the final answer here is actually going to be 1 over x to the power of 4. We hardly ever see this, but I guess it's good to look at in the student example. For E, this is more of what we'll be doing regularly, which is dealing with the coefficients and with the exponents. So here we have coefficients, 12 and 3, so we can divide those. 12 divided by 3 is 4, and then for our bases and exponents, we can subtract. So we have x to the power of 5 divided by x to the power of 1. We subtract x to the power of 4. We have y to the first power minus y to the fourth power. There we have again a negative. This is y to the negative 3 power. When this happens, the y and the negative 3 need to go down to the denominator, and that takes away the negative. So as a final answer here, it's going to be 4x to the power of 4 over y to the power of 3. Let's look at that negative exponent one more time. This example C is on page 135. So we have 27 coefficient divided by 3 coefficient. We can do that, no problem. That equals 9. And then we deal with our bases, C's with C's, D's with D's. So we have C to the power of 3 divided by C to the first power. We are going to subtract, giving us C squared. For our D's, we have D to the power of 2 over D to the power of 4. We're going to subtract 2 minus 4 gives us a negative exponent. We don't want that. When that happens, that needs to go down in a denominator. So we can leave the 9 and the C squared together up top, and we move that D down, and instead of a negative 2 exponent, it becomes a positive 2 exponent. Before we go on to multiplying and dividing some fractional polynomials, we need to review with regular fractions. So when we multiply fractions, we look to cross-reduce where we can to simplify. So 8 and 6 share 2 as a common factor. So that means they both can divide by 2. So I'm going to divide 6 by 2, which is 3. So I'll just show that over here. And I have to do the same up top across. 8 divided by 2 is 4. Now I can multiply numerator times numerator, denominator times denominator. 21 and 5 diagonal from each other. They don't share any common factors. So that's how I know to go ahead. 4 times 5 is 20. 21 times 3 is 63. And I have multiplied my fractions. Division requires an extra step. We need to keep the first fraction, change the division to multiplication, and flip the second fraction. I call it KCF. So I'm going to have 8 over 21. Instead of division, I multiply by the reciprocal. I flip the second fraction. 5 over 6 becomes 6 over 5. I look for any cross reducing that I can do. I do have with 21 and 6, both are divisible by 3. So if I catch that, that's great. And now I go ahead and multiply. 8 times 2 is 16, and 7 times 5 is 35. So multiplication and division of fractions, it's important we have that foundation for what comes next. Let's put this into action on page 135, question F, where we have multiplications of polynomials. We have them in fraction form. So here we go. We are going to cross-reduce our coefficients. 5 and 10 are both divisible by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. On the other diagonal, 6 and 8 are both divisible by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. So first we simplify the coefficients just like we do with regular fractions. And now we can go ahead and multiply numerator times numerator, denominator times denominator. We're going to multiply 4 times 2 is 8, and then check out our exponents. x5 multiplied to x to the power of 1 means we add x to the power of 6. Y squared multiplied to y to the power of 4 means we add those coefficients. That's product law. Y to the power of 6 over coefficients now on our denominator. 1 times 3 is 3. And then we have x squared multiplied to x squared. 2 plus 2 is 4. We add our coefficient, or our exponents, my bad. And then we don't have a y. We only have y squared, so we bring that along. Okay, we're not done yet. In this example, we now have to follow through and do the division step. So we're using quotient law now. Now 8 divided by 3 for coefficient is a decimal. We don't need to give a decimal. We can leave it as 8 over 3. So we leave that alone, and now we deal with our exponents. X to the power of 6 divided by x to the power of 4 means that I subtract. 6 minus 4 is 2. This becomes x squared. Y to the power of 6 divided by y squared means we subtract our exponents. This is y to the power of 4. This is our final answer. We can write it in two forms. 8/3 x squared y to the power of 4, or we can write it as 8x squared y4 all over 3. That is also allowed. Let's do one more example, division example. First thing we're going to do is keep, change, and flip. Negative 16x cubed y over 3y cubed. We get rid of division, change to multiplication, and flip to the reciprocal. This becomes negative 15xy to the power of 4 over 6xy. Notice they put the negative signs right in the middle. I'm moving them up top. Okay, you could have them both up top, both on the bottom, does not matter. Now we're going to cross reduce. 3 and 15 we divide by 3. 6 and 16 we divide by 2. We use product law. Negative 8 times negative 5 is a positive 40. X cubed times x1, x to the power of 4. Y to the power of 1 times y to the power of 4 is y to the power of 5. We're adding exponents. Over denominator, 1 times 3 coefficient is 3. X is only on one side, we keep that. Y to the power of 3 times y to the power of 1 is y to the power of 4. Now we do quotient law, we divide. 40 divided by 3 is not even, we leave it. And we simplify our exponents. X to the power of 4 divided by x to the power of 1 is x to the power of 3. Subtract those. Y to the power of 5 divided by y to the power of 4 is y to the power of 1, or just y. So you can write this two ways. 40 over 3 x cubed y, or 40 x cubed y all over 3.